Good afternoon. It's a pleasure to be here. As Matthew has alluded, it is a fair way from Cornwall. The car's got a built-in autopilot now, I think. As Matthew said, Cornwall is a unitary authority. It's been a unitary authority for 4 years now. It's also the lead local flood authority, and that meant that under the Flood and Water Management Act of 2010, we gained responsibility from the EA for ordinary watercourses, which makes for an interesting discussion at times. The highway network in Cornwall is about 2,300 kilometres, give or take, so it's a reasonably big asset. By way of background, I thought I'd put this slide up just to show you how much water influences what we do in Cornwall. There's a lot of rivers in Cornwall. It also rains a fair amount of time. In fact, the Cornish call rain liquid sunshine, and they're not being entirely facetious. The key thing on this map is the red line. What the red line shows you is in fact, the point of demarcation. So everything north of the red line flows to the north coast, and everything south flows to the south coast. So there's some fairly long flow paths there, and as you can see, a fair amount of high ground, and so we do have the potential for quite a lot of water heading towards the coastal villages, which is quite often where we get incidents of flooding. Just to try and put those rivers into some sort of context, the map or the diagram on the left shows you the catchments in Cornwall as classified by the Water Framework Directive. It's quite a lot. We use a hydrocast system to gather information and give us data on rainfall events, and we've consolidated those to the catchments on the right, but even so there's still quite a few of those. If we're talking about rainfall, I've got this from our hydrologist. This gives you a sort of indication of the distribution of rainfall. The big blue-purple patch is Bodmin Moor. The long-term average rainfall in Cornwall over those years there, giving this up to 1970, that's the best data I've been able to extract from him, is 1,150 millimetres. But that belies a sort of distribution from a minimum of about 900 millimetres up to a maximum of 1,800 millimetres, and that's just a normal year. 40% of our rainfall occurs in the spring and the summer, although if you talk to a hotelier, I'm sure they might dispute that. Distribution shows you, the top left shows you the distribution across the year by month, and then the diagram on the right is showing you distribution by catchments. The light blue is coastal Cornwall. Do I need to move this down a bit? How's that? Is that better? Yeah. The light blue is coastal Cornwall. The green is lowland Cornwall, and the red is upland Cornwall. So water becomes an issue. So we've got quite a big asset that has 7,200 kilometres. This map shows our gullies. There's in excess of 90,000 of them. We've got kilometres of ditches, grips, manholes, catch pits, etc., as everybody else has. When the pit review came out, we sat down and thought, well, shall we go out and collect data on all of these assets like we were encouraged to? Back of a fact packet told us it was about £25 million. So we thought, perhaps there's another way of doing this. So this is essentially where we are at now. This is how we have taken the data and the knowledge that we have collectively within our organisation, and I want to emphasise the fact that there will be an awful lot of knowledge in your organisations. It's just a matter of extracting that from the various grey matter databases that are available. It's important that we understand how our hierarchy relates to each other. We use the maintenance hierarchy that This is an extract from our maintenance hierarchy. It was developed using the base hierarchy that's in well-maintained highways. And the reason that I'm showing you now will become clear later on, because we use it as a basis for identifying our priority sites. We use hierarchy rather than road class because, as you will see from the distribution on this diagram, traditional classification is not really very helpful when it comes to the Cornish network. If we talk about U roads and C roads, you will see down at the bottom end of the hierarchy at the 4B level, they're pretty much interchangeable. And if you go out into the rural parts of Cornwall, you will struggle to see a difference between a U road and a C road. They are effectively one and the same thing. So we've used the maintenance hierarchy as a means of distinguishing and determining our priorities. On to the management of water now, really. This is quite a complicated chart. It's out of our preliminary flood risk assessment, and it's prioritisation of communities within Cornwall that have a local flood risk. Working from right to left, as you look at this diagram, the CDA is a critical drainage area. It's designated in conjunction with the EA, and these areas have surface water disposal issues. We know that's where there's going to be future development, so we know that we need to be thinking about SUDs when we're talking about new areas of development. And there are 29 communities in Cornwall so identified. I can skip 2 columns to the left to the CFP, which is a community flood plan. That's drawn up by a multi-agency approach in the local resilience forums that we've already heard about, and there's 24 of those. Moving back to the right, the SWMP, Surface Water Management Plan, those were identified in the previous community flood plans, and they require specific strategies in those communities. Move to the SFRA2, which is the Strategic Flood Risk Assessment and the Community Flood Risk Profiles. There's 24 communities where we know we have issues. The grid-based ranking approach, which is the second column, is the EA's ranking using the 5-inch by 9-inch grid approach, and identifies those communities have an indicative flood risk. 15 of those, and there's 8 levels. And then we have the community approach ranking, which is basically an amalgamation of all of the previous. And there's 30 communities, and that puts them in priority order as to those communities which are most vulnerable to flooding. Now, we have an issue with funding, as does everybody else, and one of the things we wanted to try and get out of our work was to target our resources where we could make them have the most effect. So when we look at things like gully emptying, our routine maintenance, we, like pretty much every highway authority that I know, originally implemented a blanket annual cleansing program. You empty the gully once every 12 months. That, pretty soon over time, showed itself to be inadequate in certain locations. So we amended frequencies. We would put the frequencies up in those areas where there was a greater incidence or a perceived risk, and we would lower frequencies in areas of perceived lower risk. But we didn't really have, it was kind of a seat of the pants approach. So taking all of the information that I've just shown you, we put it all together and identified those areas where we knew that if we hadn't made sure that the gullies were clear and that the drainage systems were working efficiently, we would inevitably have some problems. So now we have 4 levels of cleansing: 3 monthly, 6 monthly, 12 monthly, and 24 monthly. These next few slides show you Truro, which, if you will note from the previous ranking of flood vulnerable communities, Truro was the top. Just happens to be the county town. It's the major population centre. First thing you notice about Truro is there's 3 rivers that flow into it from the north, on the top of the diagram. I'm told that the name Truro means 3 rivers in Old Cornish, but I can't vouch for that personally, being from Liverpool. The rivers discharge into the River Truro, which then joins up with the River Tresillian, which then ends up in Carrick Roads, which flows to Falmouth. It's tidal. It's tidal all the way up to Truro. If you go to Truro, you'll notice that it looks like a bowl. Go down in the centre and you're looking up every which way you go, apart from down the river towards Falmouth. We've heard from the HA about flooding hotspots. We have something similar. It's perhaps not quite as formalised as the HA, but nevertheless, these are spots of known flooding that are identified by our network staff. They've been garnered from the maintenance teams of areas where they know they have to go and maintain regularly, otherwise they will have a flooding problem. It's also garnered from calls from the general public. So we have known areas where we have problems. Next bit of information, these are the flow routes from the EA, taken from their database and overlaid on our system. So we know where surface water flooding is going to occur. And you can see that the centre of Truro is a fair concentration. One of the main roads in Truro is called River Street. It's called River Street for a reason, because that's where the river used to flow. It's now culverted, but nevertheless it is there. This shows you the distribution of the gully emptying frequencies across the city of Truro. You will notice that the green in the middle is at the junction of River Street and Victoria Square. It's the low point. It's where the original bridge out of Truro used to be, if you go back to the very first maps. And the river that you see coming up from the bottom right-hand side used to flow straight through the centre of Truro. So it's not particularly surprising that when we have big rainfall events, that's where it floods. So it's on a 3-monthly cleansing programme. So that's routine maintenance. But we know that routine maintenance by itself will not always solve the problems. So we have a system of capital maintenance schemes, and we rank these using all the information that we've just discussed, but also with some significant input from our network staff. We only carry out a capital maintenance scheme if we can be assured that all outstanding maintenance has been carried out and that there has been an appropriate investigation. So we gather the information using this form, which is a proposal form. You can't really see it on the screen, but it is in the appendix of the drainage guidance document. 5 inputs. Hierarchy. I've explained the hierarchy. So the higher up the hierarchy is, the more important the road is. The risk or the impact of flooding is consequently greater. Safety issues. I'll read off the notes to guidance that we give to our staff. Safety is an attempt to highlight the potential impact of the poor drainage performance in this location. Precedents will be given to sites where there's an accident history or a causal link to standing or running water on the carriageway. Incidents of flooding. This is about the frequency and the historical record. Precedence is given to those schemes where regular flooding occurs. Structural effects. This is trying to pick up the consequential damage caused by water standing on the carriageway, whether it be through frost or erosion. And then traffic speed. we're trying to target those roads where we have a high traffic speed and therefore possible impacts of an incident are greater. This is the drainage program. It's on a spreadsheet. You can't really see it, but basically it is a way of ranking the schemes. Column M on this spreadsheet gives you whether it's in a critical drainage area or not. The HSA score, which is the last column on the right-hand side, is basically the output from that matrix that I've just gone through. So obviously the higher the number, the more important it is. The colour coding is just our way of highlighting whether the scheme is in an area where we've got other maintenance planned, or whether we're actually in the process of carrying out the works, or whether we've put it on hold, or in fact it's being withdrawn because despite having asked somebody to check that they've done all the maintenance before they nominate a scheme, we found that actually there was a drainage system there when somebody went to have a look, which does happen, unfortunately. So, this is an example of a scheme. It's relatively simple. It's 2 new gullies, road crossing, outfall into a local stream. But that's relatively high up the list. That's on a B road. It's a very busy B road, known accident spot. So that's basically how we target our resources. Now, what is the benefit of this approach? Well, to me, it's helped us to identify where we need to deploy our resources. It helps us identify where the risks lie, and asset management ultimately is about management of risk. It helps us align our service delivery with the strategy that we are trying to promote. More importantly, it helps us identify maintenance priorities, because if we think back to the gully emptying program, we now know what our core program has to be. We know how much that costs. So when we're looking at reduction in revenue funding, we know that that is a central plank of our funding. So if we come along with a 10% cut, we can't take 10% off our drainage. We have to protect the gully emptying program, which means therefore that other areas have to take a slightly larger cut in proportion. But it does help concentrate the minds of people when we're thinking about funding. So it allows us to define our core maintenance priorities. It helps us feed the budget setting process, and it assists us in highlighting funding gaps and needs. We talked about recommendations at the beginning. I sat down last week and just flicked through the 12 recommendations, and I believe the approach that I have just highlighted to you hits about 10 of the 12 recommendations. But you can only do it by making best use of the knowledge that you have within your organisations. And I would commend that approach to you. Thank you.